Hello everyone, this is Aliyah Evangelista from the Asia eHealth Information Network. Thank you for coming early to our AHIN Hour. For those who are new here, AHIN Hour is our bi-monthly webinar series where we feature topics on eHealth, health information systems, and information technology for civil registration. It's 4:01 here and we're broadcasting from the World Health Organization Western Pacific Regional Office in Manila, Philippines. Today, we're going to talk on real-time cross-platform alerting system with simple email infrastructure. Just a bit of background, when sending out alerts, disaster warnings, they should optimally be distributed via various channels. The same holds true for distributed reporting systems where multiple reports from different sources should be collected in one place. Especially for administrative officials, it might be hard to keep track of a possibly large number of incoming notifications. Tools and systems to support this procedure might be complicated or not available. In this webinar, Dr. Lutz Fromberger will present an architecture to implement a notification system by using established open source email infrastructure such as mail transport and mail delivery agents, mailing lists, and ordinary mail clients. This approach can implement a powerful notification infrastructure that does not depend on specialized services and can run on any machine. Some things to remember before we start our session: our platform, how to participate, the program, and our email feedback. First now, we're using Cisco WebEx Event Center, and if you are encountering problems as you participate, please log out the session and rejoin in our WebEx site, bit.ly.com/ahinhour, and our meeting room number is 866-827-467. Our password is Germany, capital GERMANY 123. Your mic will be mute for the rest of the meeting, but you can actively participate in three ways: by sending your feedback, by chatting your response, and by posting your question. You can send your feedback by clicking the feedback button on the right side of your screen below the participant window. And on the drop-down menu, you can respond by a yes or a no, say the presentation is too fast or too slow, and appreciate the speaker with an applause and a virtual laughter. So can we try that by sending a check to me? Just click the feedback button on the right hand side and just click yes with a check. Can we do that now? Thank you. Thank you. Thank you very much, Frederick de Guzman. How about the others? Anika, Abinat, Danilo, Gilbert, Guliwa, Dr. Jakir, Jeneline, Rowena, Dr. Martha. Thanks, Dr. Mean, Miguel, Rabin, for that check mark. I hope the others were able to locate the check marks on their screen, because later on we might be able to maximize that. So thank you. You can also chat your response by locating the chat window that is beside the participant icon. Select who do you want to chat with and then type your message in the box. Note that in this meeting room, you can only chat to either the host and or the presenter or panelist and not to all meeting participants. But I invite everyone to chat their responses to us, and I will just broadcast it to all the attendees in our meeting room. You can also post your question by assigning the question and typing your question. Just click the Q&A box or Q&A icon beside the chat icon. Our program details will run 45 minutes to 1 hour. Please send your questions to the Q&A box as it arises from your head so that we will have our questions ready before we go to the Q&A session. And lastly, please check your email so that you could check the evaluation form. We will sending all the slides and the recording of this meeting to you after you have accomplished the evaluation form. So those are the things we remember: our platform, our program details, how to participate, and our email feedback. Our speaker for this afternoon is Dr. Lutz Stromberger, who is the manager of the International Lab for Local Capacity Building, or Capacity Lab, at the University of Bremen, Germany. The Capacity Lab focuses on the use of ICT for reducing poverty in developing countries. Dr. Lutz is a computer scientist by training, and he received a PhD for his work on qualitative spatial abstraction in reinforcement learning. His research interests include machine learning, cognitive robotics, and AI technologies for geospatial mobile applications. Within the Capacity Lab, Lutz coordinates the work on Mobile 4D, a crowdsourced disaster alerting and reporting tool for Android smartphones. So please welcome our speaker for this afternoon, Dr. Lutz Stromberger. Dr. Lutz, I'm passing this ball now to you as a presenter. So how are you doing, Dr. Lutz?
Okay, I hope you can hear me now. I hope I did it all right. It's my first time using this software after training yesterday. Is everything working?
Yes, it's working well to us. Thank you.
So now I think I'm supposed to share my screen, right?
Right.
Okay, give me a second. Okay, so I tried my best to share my screen. Do you see my title slide now?
Yes, we're seeing your screen right now. Perfect. Thank you.
Okay, I don't see any chat while this works, so please interrupt me if anything is happening or if I need to react to something or all this. Okay. Yeah, thank you very much for this very, very kind introduction and all the introduction of the Capacity Lab. So I'm very honored to be able to speak here. This is, as I said, my first time doing a webinar, so I'm still a bit confused in giving a talk to people I do not see. So please bear with me if I'm sometimes a bit confused. I included a picture of myself in the border here so that you get an idea how my face would look like if I would speak to you in person. So, as it was said, the topic of the webinar I'm going now is real-time cross-platform alerting with simple email infrastructure. And the first thing I wanted to do is to give some background on the Capacity Lab. That's the institution where I'm working. I'm working at the University of Bremen in Germany, where the Capacity Lab is located. The lab itself is a research cooperation that we funded in 2012 between the University of Bremen and the UN University in Macau at that time. And what we are working on is, as Elia kindly introduced, is working on the ICT solutions for development and poverty reduction. At Bremen, our expertise is mostly in computer science. We are all computer scientists, but we have a large background also in cognitive science and artificial intelligence. So that's what we are focusing on geospatial and mobile applications for the use of development. If you're interested in more details on our project, we have a website at www.capacitylab.org, where you can find all sorts of background information. For today, the content I'm talking about today is mostly based on a paper that we had this year at the ISCRAM Asia conference in Colombo in Sri Lanka, which took place in June. The title was Keeping Track, Effective Disaster Alerting with Simple Email Infrastructure, and it's linked here. So everything I will talk about is written in detail in this paper. And the content will be that I will first talk a bit about notifications and alerts in real time, so what it means and what it's good for. After that, I will give a very short overview on one of our projects, which is Mobile 4D, a disaster alerting and reporting system that we are currently developing and deploying. and which was the motivation for this to the work I will talk about today. We will talk a bit about requirements for effective notifications, what is needed, what is wished for, and where are the problems that we need to solve. And then the bottom line of everything I will talk about today is how we can implement this kind of notification system that we want to have simply by relying on infrastructure that was made for sending emails. So I'm afraid this can be a bit technical at times. It's often a problem for computer scientists that we get carried away by our own technical fascination for something. So if anything is not clear, we have plenty of time, interrupt me, and I will try my best to explain things or talk about different things to go faster or slower as you wish. Okay, starting with alerts. An alert is by definition important, and if it wouldn't be important, it would not be time critical. So if you send out an alert, for example, a disaster warning, that's the background we have been coming from, like shown here, a tornado warning in Ohio, that's important information because it will affect lives and well-being of people. So it's very time critical. It should be sent out as fast as possible and as broadly as possible, but also as targeted as possible. So this alert should not go out to the open, but it should be exactly with the people that need to get it. So you want to have exactly the people that are affected to receive these alerts, but those should be reached reliably. And that means that you usually use all the modalities that you can get to send out an alert. I'm pretty sure you know several examples yourself from your daily work. You can send this out by SMS, you send it out by email. You have push notification systems for smartphones and also for desktop computers that are getting more popular now. Disaster alerts are distributed by Google Alerts and other web services, and they are distributed on TV channels. So whatever modality is possible, what you want to do, distribute fast, reliable, and as broadly and targeted as possible. When we are talking about notifications and alerts in this context of today, we have two directions. So the first direction is a warning that an administrative unit sends out, for example, a weather agency or a disaster agency in a government will send out an official warning to notify the public. So this is the top-down view on notification, to notify a broad public about something you need, you know that will happen. The other direction is from the bottom to the top. So that is what is subsumed under the word crowdsourcing. In the disaster case, you can report disasters from the local level by ordinary people. For example, with a smartphone application, that is what we are working on, to notify authorities about things that you know that happened that might have not been notified or noticed otherwise. So these are the two views. I will come back later to that. And we have implemented this bidirectional view on notifications in our disaster alerting and reporting system that is called Mobile 4D. I will give a very, very short overview on that because it's a very complex system and I could talk half an hour on Mobile 4D on your own. I will concentrate on only the things that are important to understand what we understand about notifications and why this, what I will talk later, how this will integrate in the work we are doing. So Mobile 4D is a notification, alerting and reporting system, and a combined one. It's based on smartphones and the internet. We have developed this together with the Ministry of Agriculture and Forestry in the People's Republic of Laos over the last 2 years. And currently, we have finished another implementation cycle, and we are now negotiating with the ministry there to roll out and deploy a larger pilot installation of Mobile 4D in Laos to test it. So it's not ready-made yet that you can just download and install it. It's still in development, but it's ready to a point that it can be used on a larger scale. The goal of Mobile 4D in one sentence is to always inform the right people and the right administrative institution about a natural hazard that can occur, and we are targeting at smaller scale hazards, like say like diseases, human diseases and animal diseases, or also plant diseases on floodings. So things that are not as big as earthquakes, but that occur on the local level and might be overlooked. And people have the opportunity to report all these hazards to the administration by making a very short report on their smartphones. So everyone can report, that's the idea. And the good thing about if you do this with a smartphone, it's that you have then a location-based service. You have GPS technology in your smartphones. That means the smartphone itself always knows where you are. So you do not need to care about giving the right location. If you issue an alert, give a report on a disaster that happens, your smartphone knows where you are, and this location is transmitted automatically to the system. And then the Mobile 4D, the system decides whom else to send this report to notify about this. This will be the right district office that is responsible for your report. This will be people in your neighborhood that could also be affected. And this is all based on the location and the administrative responsibility for this kind of alert. What is special about our system, that is bidirectional. We have a bidirectional communication. We can send out alerts from an official level based on location to the right people. And then the administration can also receive these local reports that come in by crowdsourcing, as I indicated before. So you see, the main thing that Mobile 4D works with is sending out notifications, informing people about things that happen in their vicinity, inform people about administrative officers, for example, inform them about things that happen under their responsibility, and giving them the opportunity to send out alerts then to the people that should be notified. This is a schematic representation of all this. This is the top level approach. Imagine you're in a ministry or in the ministry's administrative unit in a province or district office, and you sending out an official disaster alert. Let's say a storm is coming. This goes through exactly the province office that's in charge, the district office that is in charge. If there are NGOs operating in this area, they will also be notified. And most importantly, the alert goes through the users of the Mobile 4D system at a local level. I don't know whether you can see my mouse. No, you can't. I can't see it myself. So as you see, the people in the villages, they are equipped with smartphones and they receive the alert through, as we implemented it, push technology. It can be distributed further by SMS or email or any other modality that's possible, but the most important thing is this real-time notification by push. This is the one direction. The other direction is from the local level to the administration. And here you see you have smartphones in 2 villages, and in one village, they're sending out an alert. This goes through all the administrative layers that are in charge to the NGO that might be in charge. And the report can also go to another village in your neighborhood that can also be affected. So it's not so much important how exactly this works and who gets notified when, but what is important here is to see that we have a large number of notifications going out. If you want to notify all the people that need to be notified of a certain hazard, that can be very, very many. And this can result in a large number of reports. And on the other hand, if you have a system that empowers users at a local level to report all sorts of natural hazards and problems, this can also result in a large number of reports coming in where you need to keep track. And at this point, just imagine now that you are in charge of receiving alerts. You're working in this, you are the district officer that is in charge of incoming reports, and you had a large flooding, and a multitude of users sends out reports, asks for help, or asks for advice, what you need to do, and all these alerts come to your desk. And you need to keep the overview, and you need to react appropriately in time. So the question is, can you keep track, and how can you keep track? And this is a larger research problem that is that many people are working on. How can you keep track of all the information coming in? But it's something that all of us know from our daily office routines. So if you come back from a weekend or a longer holiday, and you open your mail program in your office for the first time, you have, I don't know, 100 and something emails at least waiting for you to be read, to be answered, to be sorted between important and not important. And this can be too many, and it's hard to keep track. So this is a screenshot that from my own mail program at some point. And you see the number of emails that are unread. I have in my university account, I had 3 unread emails, and I had 1,973 disaster alerts. Of course, these disaster alerts were just from a larger testing session that my project had been doing, but this could easily be the case. So how to keep track of 1,973 alerts that come in? So what we want to have is a solution that is simple, right? So where you don't need a specialized software or train your officers to get along with this flow of information. And you want it to be fully functional. It's important information, so we don't want to miss anything or overlook something or not be able to see the importance. So the goal of this work that we did was to come up with something that is as easy as things that people work with every day, like email, that runs everywhere and is fully functional. It allows you to keep an overview, to keep track, and it allows you to react in time. I've prepared one slide with requirements that we want to have in such a case where we are working with important notifications such as disaster notifications. So what do we want to have in such a notification? If someone reports a disaster, what we want to have is that it has, as we would say, multimedia support. So people should be able to attach images or even audio files or, depending on the bandwidth, video files to their reports. The picture tells more than any text, so it would be very, very helpful if people would be able to attach images to things they report and they are talking about. This would be one thing that would be cool. But also would be cool if it would be immediate, and that's not only cool, that's really essential. It must be an immediate notification. If a disaster is approaching, you need to immediately be notified now and not tomorrow. It needs to go out in real time at the best. You want to notify only the people that are affected. Of course, people that are affected need to be notified. But it's almost as important not to notify people that are not affected. Because if you are sending out alerts to people that don't need to care about that are not affected by this, then people will lose attention. Right? So you're getting emails that are not for you, or you get notifications that are not for you, then you begin not to look at them. And once the notification comes that's for you, then you will overlook it, and that should never happen. So you should make sure that only people are affected, only those affected people are notified. Updates is a very important thing, especially in disaster cases. Things change over time. New information is coming in. If you are notifying fast, then your notification can be out before you have all the information. So you need to be able to inform about updates. If things changed, additional information comes in. If you have additional material, tutorials, whatever, that you can give, this should be supported, and that means to keep a reference. So if you send out one notification, it should be clear. If you send out another notification with updated information, it should be clear this is an update, and it should be clear where it belongs to, right? So references is a very important thing in my opinion. Next thing, bandwidth and cost efficiency. Of course, we don't want a solution that's not expensive and doesn't burn our network capabilities and also works. It should allow reasonable organization so that it does not result in a mess and an unorganized number of notifications, messages that run around. And I think what's also important, especially in the case where we're talking about rural areas in developing countries, that it does not require non-stop internet access. So it's very usual for offices to be offline for larger periods of time because of costs, of money reasons, or just because the internet is not working reliably. But even if the internet is not working reliably, you should be able to work on the things that you can get from your network. So this is a large list of requirements, and it seems as this would call for a very complicated solution, but after we look at this, it turns out that all of those things are things that we know from something that is around on the internet, even long as the internet exists, as email. So email is a technology that's now more than 40 years old, and everybody knows it, everybody uses it. Almost no one that is connected to the internet at some point can work without using email. And all of those things I talked about, multimedia support, real-time notification, targeted information flow, keeping references, all those things are things that we find in email. When I talked to my students about they're helping with the implementation about the things that we want in our notification system, I noticed that at some point we were always saying, oh, we wanted to have like in email, but email is there. So now I will make a shift and tell you how all the things that we talked about in disaster notification and all the requirements can be realized by simply relying on things we know very, very well, that is email and email infrastructure. Is everything clear so far? Do I make sense? Can you understand me? Or have I lost you? No, still seems to work, right?
Yes, Dr. Fromberger?
Okay.
Yes, Dr. Fromberger? You stop at slide 12. Yes?
Okay. Okay. Good. First thing about a notification is what should be the content of a notification. As I said, what we want to have in the first place is text, right? All the information that we need. We have a fire, when was it reported, who was the reporter, what's his telephone number. This is all text. And of course, text can be easily sent out by email. That's not a problem. And email nowadays allows also for sending images and any binary content. So you can attach everything, every file to an email very easily with attachments in an appropriate MIME encoding. Modern email programs are also able to have HTML-based emails. So you can easily include URLs and links to internet and web resources. And a modern email client is able to render this in a very reasonable way. On the right-hand side, that's a screenshot on how Apple Mail, for example, would render one disaster report that we have. It's a test report that we did with the Mobile 4D system. You see we have links, we have information, and we have a picture and in the PDF down there attached to it. And the picture is displayed in line. These messages can be read on any platform. So as soon as we send out an email, we have a cross-platform implementation. You have email clients on your mobile phone, on your smartphone, of course, but also all the feature phones can read email. You have an email client on any operation system. As soon as you install it, the email client is there. And if not, there are web services around. So email is available everywhere. So if you render a notification as an email, all the information is in, and this problem is basically solved. That's very easy, right? This is, for example, the same notification as it appeared in my smartphone program. Here the image is not displayed in line, but it's still attached. So depending on the client you're working on, you always get the right view on your on a notification, because clients are optimized through the device that they are working on. So you don't need to care about that. Your email client is taking care of how your notification is displayed. It's a very good thing, one thing you don't need to care about. For notification, the real-time property is one of the most important things, I guess. So what becomes more and more popular and more included in all sorts of operating systems on computers are push notifications. So you notice that your computers are actually always asking you, can this and that website, is this allowed to send you push notifications? And you know what happens if you say yes, then some website will notify you as soon as content is changed or things like this. So all the operating systems now have large push infrastructures. And push technology is a really cool thing because it's real time. So you don't need to pull, so you don't need to ask, is there something new? If something is new on the other side, then you will not be notified by this side, right? The website content is changed and the website tells you by push, hey, I changed. And this happens extremely fast. And the good thing about push is that it does not require a large bandwidth. So to keep, there is a constant connection that is open, but there is very, very, very few data flowing over this connection. It's just enough data to keep it alive for a large period of time. That's almost nothing. So you have very low bandwidth consumption, and also the notification itself does not cost too much bandwidth. So this is a really, really cool technologies, and usually you rely on external services to do this. A few years back, BlackBerry was very, very famous on the mobile phone market for allowing push notifications for email. That was their main point for their sales a few years ago. Now you have these external services by Google and Apple, and you have open libraries like MQTT, that's what we are using. So you rely on some service that does the push for you. This can be quite complicated, and you need to work with some third-party service, and you need to look into the requirements and how it works. So, but there is one kind of push that's often forgotten. You know this from your email program, right? As soon as an email comes in, bing, you get the notification. So that's nothing else than a push notification. For email, this is called IMAP idle. That's an extension of the IMAP protocol. It's a bit technical now. It's just that it's very old. That existed in the 90s already. So it's basically an early implementation of push. It's widely used. Almost every client on any platform supports it, if your server supports it, which also almost every server does. So if you're working with email and you're reading your email via the IMAP protocol, which people usually do, then you always have a working push service implementation for free without having to do anything. So that's quite cool. That's another problem that we have solved. Push notifications, we're using email, we're using IMAP idle, and we are done. As we said, we want to have the location-based notification in a way that we will only inform people that are affected. And also we want to help offices that work to keep track on the locations of the notifications. That what we implemented in our mobile 4D system is a location granularity that works on a province and district level. So we have the whole country, we have the provinces, and within the provinces in Laos we have the districts. And any notification is of course assigned the exact location where the event has happened. But then we also know the district and we know the province. So we can, in mobile 4D, you see here the web front end, we can subscribe to certain districts and provinces. So if you are responsible for this and that district, let's say, you just subscribe to it, and then you receive all the messages and reports that come in for exactly those districts. So for the email-based notification system, we took over this per district basis for location-based notification. And we did that by relying on a mechanism that's also very old and that everyone knows, mailing lists. Right? You subscribe to mailing lists, and then you get all the emails that other people send to this mailing list. There are lots of software around for managing email mailing lists. This software is usually very, very old. So this is a screenshot on the right-hand side of the web front end of Mailman, which is the mostly used mailing list software. And you see from this screenshot that this web interface looks very, very old. And the reason for that is the web interface is very, very old because the software is very, very old and it hasn't changed in the last, I don't know, 15 years, at least not much. So this is very, very stable software, but very reliable, and there's no need in using anything else. So we have this wonderful mailing list system available. And what we did is we have now one mailing list for any district in the country. And also we have another mailing list for any province in the country. So whenever a notification goes out, it will be sent to this one mailing list of its district. If it's in district X, it will be sent to the mailing list district X. One subscriber of this district mailing list is the own province mailing list. So at the same time, once that this notification is sent to the district mailing list, it is also sent to the province mailing list. The good thing about that is you avoid the problem of double notifications. So if you want to keep track of this district and the whole province, then you only get this email once, because this mailing list program does that for you. It will see, okay, you get it double, then you will only get it once. So no double notifications. You don't need to care about this. Mailing list software does anything for you. So by just assigning every notification that we get the district and the province name, no, we don't even need the province name, we only need the district name. We only need the district name, and then it will be sent to this one mailing list, and all the rest will be done by the email system on our service automatically, and we end up with an automated delivery management where we do not need to care for anything. So what we do is, if people subscribe to one district in our system, they will simply be subscribed to the mailing list. They can also subscribe to the mailing list directly, but that doesn't matter, right? It's just subscribing to a mailing list, and we are sending to a mailing list, and all the stuff, the rest we don't need to care about. The rest is just sending email. One other requirement was that it would be very helpful to be able to work offline. And also, this is one thing that we know from email. The IMAP protocol is a protocol that wants you to be online, but IMAP clients support local storage. So if you go offline, you have a copy of all your emails offline on your machine, right? If you enter an airplane, it's all still there. You just cannot send anything. And as soon as you synchronize again with your mail server, you will be updated to the latest status of your emails. That's a thing that works with emails very, very reliably. And if you think about all the mess that we had in the last years with synchronizing calendars and synchronizing contacts, it was very, very surprising that this worked for email very reliably for the last 15 years or longer. So you have an offline copy of all messages. And if you go online, it's synchronized. If you go offline, it's still there. And all some important properties of your email are also synchronized, whether it is read or unread, whether it was answered or not. These are all properties of an email that are very important also for a notification. Did you see this notification? When did you see it? You saw this notification when you read the email. So you have all the very important properties that you want in a disaster notification. You also have this for an email: read, unread, important, not important. You can make it switch it back to unread if you want to have it again. So managing emails and managing disaster notifications or any notifications is more or less the same workflow if you see your notification as an email. And a very good thing is that if you use IMAP, then your email content is also synchronized over different devices. So if you read something on your smartphone and then you go back to your desktop computer, if you have read it and you synchronize there with IMAP, it's also read. So it's very easy to keep track of email, and thus it's very easy to keep track of notifications. And one of the main problems, and that's now the problem that everyone knows, is to get organized, to see what was where, how many notifications did I have for this province or for this district. And also here, as this is the same problem that people that get large amount of emails have for many, many years, your email client knows how to help you on this. And there's additional software that can help you with this. So what we have in our implementation here is that we automatically sort the email into subfolders in your email account. And we do this on a province and district basis, so you get all the notifications in, and then you have a subfolder for any province, and then in every province subfolder you have another subfolder for the district in this province. Like here in Udom, Ksai, you have Beng, Hun, Ga, and Ksai as districts in the screenshots. And all these emails will be based on the location where they occurred, will be sorted automatically on the server into the right folders. And this can be done by adding special header information in the metadata of your email that is usually invisible to you in your email clients, these so-called X headers, and then looks like this: X province, who are fun, and then it's sorted into this. Right. That only needs to be set up once. You only once have to give the system an overview on all the districts and provinces, and it's also very flexible. If something changed in the writing, so the system does not care, then you simply have new folders that you find in your email account. So you don't need to set up anything. You get a hierarchical overview, and the rest just is left to your email program. So depending on the email program that you work, you have all sorts of help for keeping track. You can mark emails and you can shift them around to different places. You can do your own subfolders. You have things as virtual folders. So you can have virtual views on your email system that you can define yourself. Wonderful. So all the things that emerged over the last 20 years to help you keep track of email can help you keep track of notification. So all that we are saying is we don't need to invent the wheel again if people have thought about this for email for such a long time. If we simply send our information out as an email, we can use all the functionality that we have and have people that know how to work with all the functionality, because reading email, sorting email, and keeping track of email is the daily business of those people over a long time. So you have not much training time and not much training effort to make them used to a new program. They can simply use their email program or another email program that they want to choose. Last thing I want here to go into detail is how to do with references. It's a kind of a technical thing, but you know that emails you can reply to an email, and then a modern email program will sort your reply to this email, so you get conversations or threads of your emails. So every email has a pointer, a reference to the previous email that it was replying to, and you usually have all the history of previous emails in your email. And that means that you have all the updates that you get displayed on top or under the original email that you get. So it's very easy to keep track, because the newest information is, depending on how you configure your email client, of course, newest information is always on top. And this is a very, very simple mechanism, but it's very, very important to keep track of these references. And you know that nowadays in email clients, this works very, very well and very reliable, and so you get a wonderful view on updates. So that was all about how we can implement all those features, and just thinking about those features as properties of email. So now, does it really work? We have, of course, bandwidth considerations that we need to take, because sending emails, right? You send out an email and another email and another email. That will, of course, cost bandwidth. And what I am recommending is to host everything on the same machine, at least in the same local network. So if you have your disaster management system that sends out all the notifications, I'd say have all your email infrastructure be hosted on the same server. If you have it on the same server, then sending an email does not produce any network traffic. It's a local delivery, it just works on your hard disk, and you don't have any traffic for all these sorting things and having emails delivered to various people. If all the accounts of the people that receive notifications are hosted on your system, then this traffic of this notification will occur only once, exactly only once, at the point when this person is reading it, transmitting it to the device, to any device to be exact, right? So it only occurs by reading. All the things like sorting, sending out to a mail server does not produce any network traffic if you host it on the same machine. Another thing that's very good about think about bandwidth is that the bandwidth problem is also not new. If you have a mobile phone, then you don't want to have this 5 megabyte attachment of the new baby of your neighbor to your phone, because it will kill your data plan. So a mobile email client usually has this mechanism to save bandwidth. It will only receive the header of the information, or it will only receive the first 10 kilobytes. And if you want to see an attachment, an image, you need to click on it to get it transmitted. So all this is already there. Saving bandwidth is nothing new. And as you have specified clients for all your devices, this also works very, very well. And you can rely on all the things being developed here. One drawback that needs to be addressed still is that email these days relies on the SMTP protocol. This is very, very old, and it's a 7-bit protocol. And that means that even for 8-bit character sets like Western ASCII or over ASCII, so everything that's 8-bit needs to be encoded, and that's even worse if you're working in Asia with usually 16-bit letters and alphabets. So you have to do a bit of extra encoding, which blows up your information a bit more than it needed to be. But that's simply a blow up about 15% of data that you need to put on top of it. Okay, I'm coming to the end. Here's again a system overview. I will use that to sum up shortly. It starts in the first box in the Mobile 4D server, so the server that sends out the alert does the email rendering. We are using Java Mail for this, which is a library in Java that simply renders emails in a correct way. Then you end up with an email that has a subject, a date, a message ID, references, and the X header information, and this will be sent to the mailing list. We're using Mailman for that, as I said, a very established program. Mailman is responsible to efficiently send out the email to all the district mailing lists and the province mailing lists, and does all sorts of load balancing not to kill your server. And this will then be picked up by the mail transport agent. There we use XIM, but can be postfix or any other. Oh no, we are using postfix meanwhile, so it does not matter which mail transport agent we use. That is then doing the local delivery. That means finding the right people to deliver to. And then it will go to the mailboxes of all the users. It can be very many. And then the sorting will take place by what's called a mail delivery agent. We use mail drop that sorts the emails to the right subfolders. And then the IMAP server, where we use Dovecot, is then responsible to communicate with the end user. And at this point, getting notifications is just reading email. As soon as a notification arrives in your mailbox, the IMAP idle system will send out a push notification to your client, and you will get your notification. One word about the specifications of our test system that we are using. We have an under-average server we are working on. It's a 4-core server with 4 gigabytes of RAM. We're using an older Ubuntu Linux version, and we are only relying on free software. So this is a very small server, or comparably small server that is, you could find anywhere. And on this system, we tested what happens from a disaster creation. So from the moment we create this report on our server until we have notified 1,000 users on the same machine, it took 11 seconds. So this is almost real time. So you can notify, let's say, I think 100 users in 1 second. I think that that's very scalable. And if you have a faster machine with a RAID system under it, then it will be even faster. Challenges that remains, as named, the bandwidth problem. We have the 7-bit protocol, and we need to decide whether we want to send HTML, which has an overhead on bandwidth, or plain text. That's things we need to decide on our side. Another challenge is setting up a mail client. Even if I said it's available everywhere and everybody knows email, that it might be complicated to some. So I noticed that many people only read email on their web front end, on Yahoo, for example. That's possible, but it's not as convenient as using a mail server, so you would need to be training people. And one thing that we ran into just a week ago, because we have the push service implemented as one email per push notification, we have also one email that is stored per push notification per user. And it's usually, unlike other push notifications, it does not vanish, it stays there. So we managed, after now 4 months of testing, we exceeded our hard disk space, which was only 170 gigabytes, which is still a lot, but that means that we need to keep track that we at some point erase all old data that's not needed anymore. Because if we save all the notifications we send out in a lifetime, then we will run out of disk space sooner or later. But this can be solved. One perspective that I see in this is that because email is working so well on any device in the world, and as I showed, notification systems can be based on email infrastructure anyway, that it would be possible to build a general notification platform that just relies on emails. That does perhaps not even needs the email to be read, but uses all the email technology to get an independent and a platform independent universal notification client. I think that should be easy, or that should be possible to develop. To sum up, what did we get? We can do a cross-platform notification system simply by relying on email infrastructure that's been available for years. It's free, it's stable, tested over centuries, decades, I'm sorry, it's tested over decades. We have all the advantages of modern email clients and all the customization for different devices. It's simple, it's easy, and it applies to any client, to any device, and anywhere in the world. And so I think it's worth trying to think about whether email can be a very easy solution to the notification problem. So I think I'm running a bit, no, I'm not over time, but almost. Thank you very much. I hope you could understand me very, very good. I hope you're still there. This is a picture of the group of people that have been involved in the mobile 4D system over the last years. That's our URL if you need additional information, and I'm here for questions if there are any. Thank you very much.
Okay, thank you, Dr. Lutz. There are some questions in our Q&A box. Let's just have a run through of these questions so that we can maximize the remaining time.
Yes.
From Dr. Mean Sambat from Cambodia, he's asking, let me just check, how do you define in advance for who are the affected or needed alert information? For whom will be the affected or needed alert?
Okay, so the question is, how do we decide who should get the notification? Yes. We do this on location mainly. So our assumption is if someone is there where something happens, if someone is there, then he is affected and he will get the notification. And your smartphone always knows where you are, so this works. The other thing is you get a notification to your home location. So you set up if you get registered as a user, you set your home location, and if something happens there, you also get notified. So that's our assumption, that we simply do it on location in the one direction, and for the administrative layer, then it goes to this administrative unit that is responsible. So if it's in district X, the notification goes to this district office and to this province office. So it's based on location and administrative responsibility.
All right. Another question is, does emailing list works for both smartphone and PC and off and online?
Yes. As mailing lists are simply sending out emails and deciding who should get an email. So this is server-sided. As a user, you do not see anything from this mailing list, and it does not matter with which device you access your email. What you get as a user is simply the email or the notification. You don't need to see anything about this, so it works for any email that is sent.
Okay, and for our last question, we have this tool in local Lao language.
That's a good question. Yes and no. So fortunately, we have Google around and Google Translate, which is now available for Lao language since 2 years, I think, almost 2 years. But so that is what we use. We have Lao translation based on Google Translate for our system. But from our experience, the result is hardly readable. So this is in very alpha stage. So at the moment we have a Lao translation, which is not very useful. But we are going to deploy a system in Laos soon, and we will get together with responsible people there and work on translating the system to proper Lao without Google Translate. So in principle, yes, it works, just that the translations that we have at the moment are currently nonsense, but that will be worked on soon.
All right, because I know that many of our Asian members, and especially those from Cambodia and Thailand, are really interested in translating systems to their local languages. All right, so I think we're on. If you have other questions, we will make our emails available for our participants to email their questions, and I will just send it to our resource person, Dr. Fromberger. Any last message to those who are planning to adopt this, most especially for those countries who are in hazardous areas? Dr. Fromberger, any last message from those people who are in disaster-prone areas?
Okay.
That's what I mean, sorry.
I don't have a last message for this, I think. I'm not prepared for that.
All right. So I think this what you've showed a while ago is really helpful because the resources are available and free, and users can customize it to their local needs. All right. So thank you very much. Please check your emails for our feedback form, and we will be sending you the slides of Dr. Lutz Stromberger and the recorded link so that you could also share this to your teammates, most especially those who are working in their government offices and ministries. So that's it. Thank you very much. See you on our next Regional Alien Hour. That is on the second Wednesday of the month. That is October 8th. And we will be happy to also welcome your thoughts and evaluations at the end of this meeting. So thank you and goodbye. Have a great day. Thanks, Dr. Lutz.
Yeah, thanks. It was a great pleasure. Thank you again.